Consider the animation. Over here, an ebonite rod is being rubbed with fur. And as you know, negative charges are getting developed on ebonite rod and positive charges on the fur. Now, how do you think we can detect these negative charges that are getting developed on the ebonite rod? Let us find out. So in order to detect the presence of charge on any body, we use what is known as an electroscope. An electroscope is a device which is used for detecting the presence of electrical charge on any body. Now, this device is known as a pith ball electroscope because it employs a pith ball in order to detect charge. So the structure of a pith ball electroscope is as you see. It is suspended from a hook with the help of a silk thread. Now this hook is made of copper and the entire arrangement is placed on an insulated stand. So this is the structure of a simple pith ball electroscope. So let us see how a pith ball electroscope works. In this video, a similar thing is being done. Over here, when an uncharged body is brought near the pith ball, you will find that there is no deflection. So when the uncharged hand of the man is being brought near the pith ball, there is no deflection. But an ebonite rod is rubbed with fur and brought near the pith ball. As you can see, initially it gets attracted, and then once it touches the ebonite rod, it gets repelled. So let us see why this is happening. So initially an uncharged body was brought in front of the pith ball, and obviously as you saw, the pith ball was not deflected and it did not move. Next, the ebonite rod that was negatively charged was brought near the pith ball. So when the negatively charged ebonite rod is being brought near the pith ball, it is found that it is getting attracted. Why? This attraction is taking place due to electrostatic induction. When a negatively charged rod is being brought near the ball, the electrons on the rod side of the ball are getting repelled because a negative charge is coming in. So once these electrons get repelled, they move to the other side of the ball where they accumulate. So on the other end, that is the rod end of the ball, positive charges are left behind, and that is why these unlike charges attract the negatively charged rod and the positively charged side of the pith ball. And as a result, it gets attracted to the rod. Now the moment the rod touches the pith ball, it gets repelled. Why? Because in that case, after touching, conduction takes place. So the electrons from the negatively charged rod travel to the pith ball. Now once these electrons move to the pith ball gets negatively charged, and we have studied that like charges repel one another. So on making contact with the negatively charged ebonite rod, the pith ball gets repelled. So initially it got attracted due to electrostatic induction, and on touching, due to conduction, the pith ball got repelled. So we see that the movement of the pith ball when the body to be tested is brought near the ball. When there is no movement, we can say that the body is uncharged. And when it moves towards the body, we can say that the body is charged. Now I have a question for you. The pith ball electroscope can detect charge, or it can determine the type of charge also. Which one do you think is the answer? The answer is the pith ball electroscope can only detect the charge. It cannot tell us whether the type of charge on the body is negative or positive. So it is for this reason that a pith ball electroscope is not used. Another reason why the pith ball electroscope is not used is because the pith ball is a very light thing. So instead of only movement due to charges, it can also get displaced if there is a flow of air in the room where it is kept. So because it is very light and can be disturbed by the flow of air, and also because it cannot determine the type of charge, we do not use a pith ball electroscope for this purpose. Instead, we use a slightly different electroscope, which is known as the gold leaf electroscope. Now, as you can see, this picture is that of a gold leaf electroscope. So let us talk about how a gold leaf electroscope functions. Firstly, we are going to watch a video where we will find how a gold leaf electroscope is functioning. Over here you will find that a man is rubbing a rod on fur and bringing it near the cap of the gold leaf electroscope. And the gold leaves, you can see, are diverged. Now the moment the man presses the cap, these gold leaves collapse. So let us find out what exactly is happening in this. Firstly, we consider the structure of a gold leaf electroscope. Now this is the condition where the gold leaf electroscope is uncharged. So an uncharged gold leaf electroscope looks somewhat like this. There is a cap on the top of the gold leaf electroscope which is mounted on an insulation. This cap is insulated from the copper conductor that you can see lying inside the glass case. Now at the end of the copper conductor, we have two gold leaves. This is where the charges accumulate, and through the movement of the gold leaves, we can tell what the charge on the body is and whether it is charged at all. So let us find out how we can test the same. So if there is no charge present on the cap of the gold leaf, then the gold leaf will be in fully collapsed position. So no charge on the gold leaf electroscope cap means that the leaves will be in collapsed position. So let us see now what happens if we touch a negatively charged rod with the cap of the gold leaf electroscope. When we touch a negatively charged rod with the cap, the electrons, the excess electrons that are present in the negatively charged rod flow down due to conduction. They flow through the copper conductor and get accumulated on the gold leaf. As a result, the gold leaf diverges, as you can see clearly from the animation, due to repulsion between the accumulated negative charges. So as you can see, when we are charging the electroscope with the help of a negatively charged rod, negative charges are flowing down the copper conductor and getting accumulated in the gold leaf. So since like charges repel one another, these accumulated negative charges will repel one another, as a result of which the gold leaf will diverge. A similar thing happens when a positively charged rod is touched with the cap of the gold leaf electroscope. In this case, when the positively charged rod is touched, the electrons from the gold leaf travel up through the conductor and reach the bar due to conduction. So there is a deficiency of electrons in the gold leaf, as a result of which positive charges are left behind and are accumulated on the gold leaf. So due to the presence of these positive charges, which are like charges on the gold leaf diverges from its collapsed position. Now we have the charged electroscope due to a positively charged rod. As you can see from the previous animation, what was happening is when the positively charged rod is touched with the gold leaf cap, these electrons are flowing upwards, and it is creating a deficiency of electrons in this region, as a result of which positive charges are left behind, as you can see. So these accumulated charges are like charges, and due to this, the gold leaf is getting repelled, because like charges repel one another. Now using a gold leaf electroscope, we saw that we can find the presence of charge on a body by the principle of electrostatic conduction. Now using the principle of electrostatic induction, do you think we can find the presence of charge on a body? Let us find out. So when we are using electrostatic induction, that is, we are not touching the body with the cap. Let's see what happens. A positively charged body is brought near the cap. So as a result, it attracts the negative charges from the gold leaf. These negative charges flow up and get accumulated on the gold cap, and it leaves behind positive charges because there is a deficiency of electrons at the gold leaf. So these accumulated positive charges on the gold leaf causes the gold leaf to diverge from its initial collapsed position. Similarly, when a negatively charged rod is brought near, what happens is it repels the electrons that are present on the gold leaf electroscope cap. So when these electrons are repelled, they travel down through the conductor and accumulate on the gold leaf, and it leaves behind positive charges on the gold leaf electroscope cap. So these negative charges that are accumulating on the gold leaf causes the gold leaf to diverge, because these accumulated negative charges are like charges, and the gold leaf diverges from its initial collapsed position. Now we found out that we can detect the presence of charge using gold leaf electroscope. We can also detect in what way the body is charged if we initially use a positively charged gold leaf electroscope. So in the case of a positively charged gold leaf electroscope, we find that positive charges are residing everywhere, starting from the cap to the gold leaf. And initially, the gold leaf is in a diverged or repelled position. So let us see how we can detect what kind of charge or determine the kind of charge that is present on the charged body. Firstly, we use conduction. Here a body is touched with the gold leaf, and we find that the divergence of the gold leaf is increasing. So this gold leaf is already positively charged. So under what condition will the divergence increase? It will increase only if the positive charge increases further. How will the positive charge increase further? If it loses even more number of electrons. Now since we are touching the body with the gold leaf cap, we can say that this body is a positively charged body, because it is attracting all the electrons from the gold leaf, and these electrons are flowing through the conductor and into the body. So as a result, it is increasing the positive charge on the gold leaf, which is why it is diverging more. Thus we can conclude that the body being touched is a positively charged body. Similarly, if we touch a body, in this case we find that the divergence is decreasing and the gold leaf is collapsing. Now when will the gold leaf collapse? The gold leaf will collapse only when the positive charges on the body of the gold leaf becomes less. How will it become less? Only when these positive charges are neutralized by negative charges. So since we are touching the body with the cap of the gold leaf, we can say that only when electrons flow down through the copper conductor and into the gold leaf, these positive charges will be neutralized. Thus, we can firmly conclude that the body which is being touched with the gold leaf electroscope, due to which the gold leaf is collapsing, is a negatively charged body, because it is reducing the positive charges that were already present on the gold leaf electroscope. Now let us see how we can determine the same through induction. Over here we are bringing a body near the gold leaf cap, and we find that the divergence is increasing. Now as I discussed, for the divergence to increase, there has to be a decrease in the number of electrons, which means an increase in the positive charge of the gold leaf. Now that is only possible when electrons flow from the gold leaf to the cap. So in order for that to happen, there must be an oppositely charged body being brought near the cap. So thus we can affirm that since the divergence of the gold leaf is increasing, a positively charged body has been brought near the cap. In a similar manner, when the divergence of the gold leaf decreases, it must be happening because of a reduction in the positive charge. There is only one way in which the positive charge can reduce, that is if an equal number of electrons come in and neutralize these charges. For electrons to flow through the conductor, these electrons must have to be repelled from the cap of the gold leaf electroscope. So we can affirm that since the electrons are being repelled from the top to bottom, a negatively charged rod has been brought in, which is causing the gold leaf to collapse. Thus, concluding what we have learned so far, we can derive these following conclusions. When the charge on the gold leaf is 0, that is when the gold leaf is uncharged. The effect on the divergence of the leaf when the body to be tested is brought near the disk or touch with the disk. So when the body is uncharged, in such a case, if we find there is no divergence, then the body is neutral. And if we find that there is divergence taking place, then the body to be brought in is charged. Under the circumstance that the charge on the gold leaf electroscope initially is 0 or the gold leaf electroscope is uncharged. So this is merely for charge detection. For charge determination, we charge the gold leaf positively. And we can say that when the divergence is increasing, then the charge on the test body is positive. And when the convergence is increasing, or in other words, the divergence is decreasing and the gold leaf is collapsing, then the charge on the test body is negative. This is how a gold leaf electroscope helps us in deciding the charge that is present on the body as well as detecting charge on the body.